So in this lecture, we'll talk about basic components that you see in embedded systems commonly, different versions of what you will eventually use in the class. So development board is very common. On the development board, you see circled in red is a microprocessor, microcontroller actually in that case. It looks like a Freescale. Yeah, and this is a board from my office actually. This Freescale board has a Freescale processor on there, and you can program it from a host. So you go to a host like that laptop that's pictured there. You type in the code, you compile the code, and you connect the host to the development board and transfer the data to the microcontroller. So you usually do your programming on the host. Not always. Like with a Raspberry Pi, as we'll see, you can actually do the development on the Raspberry Pi itself if you want to, but it's most common to do it on a host because a host is generally a more powerful platform, easier to program on. So as far as processors go, there are, and microcontrollers as well, but right now just talking about general purpose processors, you can classify them in, say, two broad categories: general purpose and digital signal processing. So general purpose processors, those are what you see in your standard desktop laptop. They're used for any application, and they include many features, but they're overkill for most features. They have many features that you probably don't even need, but they can handle anything. So any particular task, they can do it. They can do it adequately. But they tend to be more expensive because they're over-designed, right? They're over-engineered, and they have many features that maybe you don't need a lot of them, but they have it just in case. So that's a general purpose processor. There are also digital signal processors, which are specific to doing digital signal processing applications. So digital signal processing is basically processing data streams. So audio streams, video streams. These are common. These are very common. You know, maybe you want to, as audio is coming in, you want to filter that audio, or you want to compress that audio. Or same thing with video. Same thing. You might want to filter it, or do some special effect, or compress it, or something like that. So these are big streams of temporal data over time, and you want to do some processing on it. Digital signal processors are actually good processors to do that with. And they're made for that, with that in mind. They have special instructions for that. They have what are called vector instructions. So vector instructions are instructions that do the same thing to lots of different data. So for instance, say you got add, right? With add, you might take two numbers and add them together and get a result. So a vector add might take 32 numbers, add them to another 32 numbers, and get a 32 number result. So it just does the same thing for many pairs of data, many sets of data. And this is very common in signal processing. So imagine you're processing video, right? You got some image with 1 million pixels, which isn't even a lot. And you want to perform some blur or some operation to the pixels. Whatever operation you perform to one pixel, you want to do that to all 1 million, the same thing. So vector operations are very useful for things like that. You can just do things in parallel very quickly. So sensors are extremely common. You need some form of sensors, and sensors just receive information from the environment. There are lots of different kinds of sensors. Let's generally say you can have simple sensors that receive, say, heat information, like thermistor, that receives temperature information. Photoresistor reports light intensity, right? So these are generally simple sensors. I'll call them simple sensors because their inputs and outputs are just real numbers, right? 0 volts to 5 volts, right? So it's bright or it's not bright, something like that. But complex sensors can actually receive much more complicated data. So for instance, take a camera, a CMOS camera, a camera in, like in a digital camera. So it captures images. Now that's a light sensor. It's technically a light sensor. It's a special purpose light sensor. It doesn't just tell you the intensity of light like a photoresistor might. It also tells you what color the light is at every point in the image, right? So it's much more complicated visual data that this thing is reporting. So it can't just give you one number, 0 to 5. Yes, this is bright. No, it's not. It has to give you, say it's a megapixel, 1 million pixels of image data to represent what it's capturing. So this is a sensor. It's still receiving data from the outside world, but it's a much more complicated sensor. So there's a lot more data to receive, and it's more complicated to work with generally. Now, we can still work with them, but you generally have to know a little bit more about the circuitry in order to do that, or use library functions, which we will talk about later. Now, also an Ethernet controller. You can see that as a sensor. Whether that's a sensor or not is a question. It's a sort of a judgment call. But an Ethernet controller will allow you to receive information on the from the Ethernet, from the network. So that information, you can call that sensing not necessarily from the physical world, but sensing from the network. So, and the type of information that we receive over the network can be very complicated. So that's a more complicated form of a sensor, more complicated to use. Actuators, they cause events to occur in the environment. There's some simple ones. LEDs, light emitting diodes, they turn lights off and on. LCDs, displays, liquid crystal displays, that's like what's on my digital watch, right? You've seen these. They're not backlit, so they're not as bright. But they're low power, but they're useful. And so those that you can put numbers on them, something like that. So that's a relatively simple display. You can also have more complicated actuators, like a servo motor. So there are motors, DC motors. Servo motors are a little bit more complicated. You can control the angle, the precise angle to which the motor turns, which is useful in a lot of cases, like, say, a robot arm or something like that. Ethernet controller can also be thought of as an actuator because it can output data to the environment. If I consider the network itself to be the environment, then an Ethernet controller allows you to output some messages, some message data to the network and send it out to wherever you're going to send it to. But these are more complicated sensors, or actuators, I'm sorry. Thank you.